To wrap up our study of Venn diagrams and sets, we're going to take a look at something called De Morgan's theorem. De Morgan's theorem talks about the interaction between two sets A and B. Potentially they have an intersection. They don't have to, but my diagram here will allow for it. If they don't, the same theorem actually holds whether they intersect or not. And so there are two forms of De Morgan's law. First of all, if you take A intersect B and then look at its complement, it'll be equivalent to the complement of A union with the complement of B. So what I want to do is show you first of all that that statement is true, then we'll discuss the other one. This first one then, what I want to do first of all is just identify which regions are contained within each statement and show you that they are equivalent, the same regions on the Venn diagram, and so the same elements will be in each set. Okay, so these are basically sets, right? A and B are sets, and so their complements are sets, their intersections, these are sets. And so the equivalence of two sets just means that they contain the same elements. In a Venn diagram, that's equivalent to containing the same regions. Okay, so let's first look at A intersect B. Well, A intersect B is region 2, right? So this portion is region 2. When you look at the complement of region 2, that's basically everything else, right? So the complement of region 2 must be 1, 3, and 4. So this entire side must be regions 1, 3, and 4. Okay, so it's the complement of region 2. Now let's take a look at the other side and see if it matches up. Okay, A complement. Well, first of all, if I think about A contains 1 and 2, so its complement must be 3 and 4. Okay, those are all the elements that are not in A. So A complement is region 3 and region 4. Okay, B complement. Well, let's think about B. B is 2 and 3. So B complement must be 1 and 4. Okay, so B complement is all of the elements that are not in B itself, 1 and 4. Now we look at their union. So the union of these two sets is any region that is contained in one or the other or both. Okay, well, region 1, region 3, and region 4 are contained in one or the other or both. The only region missing is region 2. Okay, so that means together, draw it this way. Together they make up regions 1, 3, and 4, which are exactly the same regions we got before, which proves that the two sets are the same. So the complement of an intersection is exactly equivalent to the union of the individual complements. Okay. The other statement over here says that the complement of a union is the intersection of the complements. Okay, so it's just switching the union and intersection idea. So let's again identify the regions for each of these sets. So if you look at A union B, that's all of the elements in one or the other or both. Okay, and correspondingly the regions here in the Venn diagram. So A union B would be 1, 2, and 3, right? Regions 1, 2, and 3 are contained in one or the other or both. Okay, but now I want the complement of that, all right? So the complement, as I come down, is only region 4. Okay, that's the only thing that's not in regions 1, 2, and 3. Okay, so now let's take a look at the other side. I want A complement. Well, A complement, if I think about, it's the same as we had before, it's 3 and 4. Why did I write those arrows the other way? I want to actually write those down. We're building this downward. I don't know. So A complement is regions 3 and 4. Same as before, right? A is 1 and 2, so its complement is 3 and 4. B complement, well, B is 2 and 3, so its complement is 1 and 4. And the intersection is all elements in both, right? In both A complement and B complement. Well, the only thing in both is region 4, okay? Since that matches the region that we had before, to the other side, the two sets must be equivalent. All of the elements that are in region 4 on the Venn diagram will be in the complement of the union and will also be in the intersection of the two complements, okay? So very important law stated in two different ways, or two different sets, I guess. 4 sets, 2 of them are equal and 2 of those are equal. So